Hey everyone and welcome back to CodeMechanic. Today, we're diving deep into one of the most critical components in your car's engine management system, the oxygen sensor, or O2 sensor. Ever wondered how your car magically knows how much fuel to use? Well, this little guy is a huge part of that magic. It's the nose of your engine, constantly sniffing the exhaust fumes to make sure your air-fuel ratio is just right. Get it wrong, and you're looking at poor fuel economy, failed emissions tests, and that dreaded check engine light. So, stick around as we break down how it works, how it fails, and what to do when it does. First, let's talk about what an O2 sensor actually does. Your engine is designed to run most efficiently at a very specific air-to-fuel ratio, known as the stoichiometric ratio, which is about 14.7 parts air to 1 part fuel. The O2 sensor, located in your exhaust pipe, measures the amount of unburned oxygen in the exhaust gas. It then sends this information back to the engine control unit, or ECU, as a voltage signal. A high voltage signal, usually around 0.9 volts, means the mixture is rich too much fuel and not enough oxygen. A low voltage signal, around 0.1 volts, means the mixture is lean, too much oxygen and not enough fuel. This constant feedback loop is what we call closed-loop operation. The ECU receives the O2 sensor S signal and makes real-time adjustments to the amount of fuel being injected into the cylinders. It's trying to keep that air-fuel ratio oscillating perfectly around that 14.7 to 1 sweet spot. These adjustments are called fuel trims. You have short-term fuel trims, which are immediate corrections, and long-term fuel trims, which are learned adjustments over time. When your O2 sensor is working correctly, you'll see these fuel trim values hovering close to 0%, meaning the ECU isn't having to work too hard to maintain the ideal mixture. This process is crucial for maximizing fuel economy and minimizing harmful emissions. So, what happens when an O2 sensor starts to fail? Over time, they can get contaminated by things like carbon, oil, or even coolant, which makes them slow to respond or sends inaccurate signals. A lazy O2 sensor won't switch between high and low voltage quickly enough, causing the ECU to make sluggish adjustments. A biased sensor might get stuck reading high or low, tricking the ECU into thinking the engine is constantly rich or lean. This can lead to a host of problems, from a rough idle and engine hesitation to a significant drop in your miles per gallon. And of course, it will trigger your check engine light. When that light comes on, you'll likely see diagnostic trouble codes, or ranging from P0130 to P0167. These codes point to specific sensors and their circuits. For example, codes like P0130 or P0131 usually point to an issue with the upstream sensor on bank 1, which is the primary sensor the ECU uses for fuel control. Codes like P0137 or P0141 might indicate a problem with the downstream sensor, which primarily monitors the efficiency of your catalytic converter. Don't just replace the sensor based on the code, though it's crucial to look at the live data with a good scan tool. Watch the voltage signal of the upstream sensor. A healthy one should rapidly fluctuate between about 0.1 and 0.9 volts once the engine is warm and in closed loop. If it's flatlined, stuck, or switching very slowly, that's a good sign it's time for a replacement. Also, check your fuel trims. If your long-term fuel trims are way off, like plus or minus 10% or more, it's a strong indicator your engine is compensating for a faulty sensor. When it's time for a replacement, here are a few tips. First, always disconnect the battery. Use a proper O2 sensor socket, which has a slot for the wire, to avoid damaging it. These sensors can be really seized in the exhaust pipe, so a good dose of penetrating oil beforehand can be a lifesaver. When installing the new one, make sure to use a little bit of the anti-seize compound that often comes with it, but only on the threads. Be careful not to get any on the sensor tip itself, as it can contaminate it. Tighten it to the manufacturer's specified torque. Reconnect everything, and clear the codes. A new O2 sensor can bring your engine's performance and fuel economy right back to where it should be. And that's a wrap on oxygen sensors. Understanding how they work is key to diagnosing and fixing a wide range of engine performance issues. Hopefully, this gives you the confidence to tackle that check engine light yourself. If you found this video helpful, give it a thumbs up. And don't forget to subscribe to CodeMechanic for more deep dives into how your car works. Thanks for watching, and I'll see you in the next one.